Okay, so we're going to be taking a look at the negative and zero exponent rules. These are two separate rules here, so let's take a look at these here. The negative exponent rule says that if you have a base raised to a negative exponent, so -1, -2, -5, something like that, you can rewrite it as 1 over that base to the power of the positive exponent. So obviously, let's take a look at an example. It'll make a lot more sense here. Let's suppose we have 2 to the -5. If you have 2 to the -5, I can write that as 1 over 2 to the 5th. Likewise, if I have 3 to the -4, I can write that as 1 over 3 to the power of 4. Okay, continuing on here, we also have the zero exponent rule. And the zero exponent rule, what it says is it says that anything raised to the power of 0 is going to be 1. So 2 to the power of 0, 1. -125, the entire expression raised to the power of 0 is 1. 1/2 to the power of 0 is 1. Pi to the power of 0 is 1. The root of 2 to the power of 0 is 1. I think you guys get the idea. Even if you have an expression inside, like let's say you have 1/2 plus 2 squared plus 3, that raised to the power of 0 is also 1. Okay, so let's take a look at some examples applying the zero exponent law and negative exponent law. So for the first one here, we've got 9 to the power of 0. Again, anything to the power of 0 is 1. Now this one here is interesting. If you take a look, the power of 0 is really only being applied to the number 9. It is then being multiplied by -1. So if I could rewrite this as negative bracket 9 to the power of 0. Therefore, this is just -1 as your answer. Because that 0 is only applying to the 9, so this is really going to be -1 times 1, which is -1. On the other hand, with this question, this 0 is being applied to the -9, the whole expression, in which case that is going to be a 1. So just take note of the difference between these here. The brackets matter for these zero exponents as well. Let's take a look here. Anything to the power of 0 is 1, even if it's a fraction. This here, the 0 is being applied to the 2/3. So this would actually, has nothing to do with a 5. So this would actually be 5 times 1, which is 5. For this one here, you still have to use your bedmass rule. So B stands for brackets. So I have to take care of what's in the brackets first. So in this case here, 2 to the power of 0 is 1, 3 to the power of 0 is 1, and 5 to the power of 0 is 1. Still taking care of what's in the brackets, this becomes 3 to the power of 0, which you guessed it, is 1. Okay, let's take a look at the next one. Now we're looking at negative exponent rules. So with the negative exponent rule, this would be written as 1 over 2 to the 4th. You can drop that negative sign, but it costs you. You have to flip that base to the bottom. So now 2 to the 4th is 16. This would be 1 over 16. Now again, this exponent is only being applied to the 2. It is not touching this minus sign. And because of that, I could rewrite this as -1 times 2 to the -4. Which means this is -1 over 2 to the 4, which means this is -1 over 16. Whereas with this question, this is 1 over -2, the entire expression, to the power of 4, which will now be 1 over positive 16, because -2 to the power of 4 is positive 16. Okay, so take a note at the differences between these here. They matter, and these are a lot of areas where students have issues. Okay, last, let's take a look at these next two here. So this one here, okay, this is obviously the negative exponent rule, so let's go ahead and apply it. So if I apply the negative exponent rule, it says you take your base. In this case, my base is 2/3, I bring it to the bottom. Well, when you square a fraction, you square the top and square the bottom. So that means this will end up being 2 squared is 4 and 3 squared is 9. Now you're kind of going back and you're looking at dividing integer by a fraction. So whenever you do this, you rewrite the 1 as a fraction. And now what I have here is really, this is just 1 over 1 divided by 4 over 9. And whenever you divide fractions, you change it to multiplication and flip, in which case this is 9 over 4. Likewise with this one here, this minus 2 is only being applied to the base of 2/3. So this will end up being 3 over 2/3 squared, which is going to be 3 over 4 over 9 like we're talking. And then once again, this is equivalent to writing 3 over 1 divided by 4 over 9. And when you take fraction divided by fraction, you multiply by the flip, and in which case here we get 27 over 4. In general, if you're looking to divide a fraction out with a -1, that just becomes 3 over 2. If you're given 5 over 6 to the -1, that just flips, becomes 6 over 5. If you're given, and like we saw, if you're giving 2 over 3 to the -2, that just becomes, you flip it and change that sign to positive, right? In which case that becomes 9 over 4. In general, if you have an m over n and raise that to the -1, that is going to equal n over m. It just flips and you lose that sign. Okay, that concludes zero exponent rule and negative exponent rule. Please review these here. These are very common mistakes that students make with the minus signs and forgetting the brackets, and exponent is applied to the base and not something that is not connected to the base. Okay, thank you.